Now that you know how to count significant figures, what happens if you have to add two measurements together? For example, if you use this balance to weigh something and it says 1.0, because the balance is not that precise or accurate, it only has one decimal place. And then you use, the next day, you go to another lab perhaps, and this is in grams, by the way, and they have this sensitive balance, and it's able to read 6 decimal places, 1, 2, 3, 4, 5, 6. And you want to add these two numbers together. The answer will be 2, but how many digits do you report? Because the first number was derived from a balance that's not very accurate, this number right here is a certain digit, and this number is an uncertain digit. When you add them, you only get one uncertain digit. So that means that you're only allowed up to the 10th place. Okay. If you look at this number, the second number, even though these are significant, and certain, and uncertain, when you add these two zeros together, a certain and an uncertain, this number becomes uncertain. Therefore, you may not add more digits after. So this is the certain digit plus one uncertain digit. You have 2 significant figures in your reported answer. So the question is, how do I know how many significant figures to report when adding or subtracting numbers? Well, you want to round the final answer with the same decimal places as the number with the least digits after the decimal, or I call them DADs. This one has 1 digit after the decimal. This one has 6, which is the least, 1. So you get 1. Your turn. Subtract these two numbers. Pause the video. When I subtract these numbers, I can get 3.89 meters. But the rule says that I have to use the number with the least significant digits. Since this one only has 1, I can only report 1 significant digit. I have 1 digit after the decimal here, which is the least. So my answer, I have to round that 8. And because this is a 9, I have to round up. So 5 and up, you round up. 4 and below, you round down. So my answer will be 3.9 meters. I only have 1 digit after the decimal because this number only has 1 digit after the decimal. When you're multiplying and dividing, the rule changes a little bit. Okay, so for this one, the rule is round the final answer with the same number of sig figs as the number with the least total number of sig figs. For example, when I'm multiplying these 3 numbers, 1 times 2 times 3 equals 6 centimeter cubed. So I wonder, well, how do I know how many to report? How many zeros after? Or how many decimal places? To know that, you count the total significant figures. This number has 3 significant figures. This number has 2. This number has 4. So whoever has the least total sig figs, the least is 2, then I'm only allowed to have 2. Therefore, I will put 6.0 centimeter cubed. Your turn. When dividing these two numbers, what do you get? Pause the video. Okay, the answer should be 5. But since this number has 2 sig figs, this number has 4, the least is 2 sig figs, then I can report 5.0. The units are meters per second. Okay, the rules for rounding are as follows. When you have 5 and up, you round up. 4 and below, you round down. For example, round these numbers to 3 significant figures. So you count 1, 2, 3. You round the 6, the third significant digit, equals 4.2. Because that's 4 and below, you stay at 6. Pause the video and do the rest. Okay, so this one has 3 sig figs. 1, 2, 3. That's the third significant digit. So you go 2, 6. Because it's 5 and up, you round up. It would be rounded to a 6. That has 3 significant digits. Doing this one, 1, 2, 3, you round that number, 1,204, and then I put a 0 as my placeholder. This will give me 3 significant digits. Okay. If I have a number here that I want to report to 3 significant figures, but it's 1,000, how do I do it? I can't write that because now it's 100. So what I have to do is change this to scientific notation. So to change it to scientific notation, it's the 1 times 10 to the 4th power. Now if I wanted 3 significant digits, I do 2 zeros after will give me 3 significant digits, and that's how you do that problem. Stop the video and do the rest. This one says 1 digit after the decimal, so this is 1 digit after the decimal rounds to 5.7. This rounds to 23.5, and this rounds to 44.7 because you rounded up.